So we have here sample problem 4.8. 4,000 pound weight is attached at A to the lever shown. The constant of the spring BC is 250 pound-inch, and the spring is unstretched when theta is 0. Determine the position of equilibrium. So for this problem, we have a spring and a weight attached to this rod here. It says that this problem, when theta is 0, our spring here is unstretched. Now, when we put 4,000 pound weight here, our spring here is stretched by an amount theta. The question here is, we need to determine the position of equilibrium. So at what value of theta would this system be in equilibrium, or all forces here balanced out? Okay, so what are the forces in the system? So as you can see here, we have a hinge. So our hinge here, since it's a hinge, it has components along x and y for the support. And for our spring, this spring would somehow exert a force that is equal to k times s. So that's the force of the spring. And we have here 4,000 pounds going downward vertically. Okay, so as you may see here, we have our FBD. For the force, spring force, the formula is just the spring constant times the stretched distance. So we have our stretched constant given, and that is 250 pound-inch. And then our weight directed towards the negative, we have 4,000 pounds. So we have here, 400 pounds. Okay, now take a look at here. Our spring force, that is equal to k times s, where our k is 250. Our s here is basically, when we have our spring at theta is equal to 0, it's unstretched. And after putting a load of 400 pounds, it is stretched to a theta, wherein this theta here is what we want to find, no? What value of theta wherein everything here balance out. Okay, so as you may see here, this theta here, this is the stretched length of our spring. And as you may see here, this is just a length of an arc of a circle. So to get the length of arc of the circle, the formula is just r times theta. So we may replace the stretched length of the spring by the constants, the variables r theta. That's the formula in getting the length of arc. Okay, now we can apply the three equilibrium equations here. For this example, we can use summation of moment at a point where there are many unknowns. So in this case, we have our point O. It has unknowns Rx and Ry. So we can apply the summation of moment at point O, counterclockwise positive. So that would equal to 0. That will be 0. What are the moments at point O? So we have only two forces here, the weight and the spring here. So for the spring, force of the spring, the perpendicular distance from point O up to our force here is this distance here. That is just actually the radius of our circle. So force times distance, we have force times r. Okay, and it tends to rotate this drum clockwise, so this would be negative. And how about the weight? Weight is positive. Its value is 400. And how about the perpendicular distance? How did we get this sine theta here? So as you may observe here, our theta is this one. Okay, and if we draw a horizontal line here going to this here, we can create an angle 90 here. And we know that this angle here, this one here, this is our theta. And knowing that the length from here to here, it should be here now, this one. Ayan. This angle here, this is our theta. The length of this one here is L. So therefore, the length of this one here, opposite, so we have L sine theta. That's why we have L sine theta written here. Okay, so that would be its moment arm. We have here L sine theta. That is equal to 0. So our f here is just kr theta. So let's substitute. We have here negative kr theta plus 400 times L sine theta is equal to 0. Now, if we try to transpose this to the right side, we have here 400 L sine theta is equal to kr theta. So divide both sides by 400L. We have here 400L. So cancel. We have here sine theta is equal to kr theta over 400L. Substitute. We have our k as 250. Our r here, the radius, it's 3. So we have 3 here. And then we have theta over 400 times our length. Our length here is 8. So we have times 8. That would be equal to sine theta is equal to 0.703 theta. Now, how can we solve for theta? We cannot just transpose this sine theta to make it sine inverse, no? Because we have here another theta on the right side of our equation. So what we do to solve for theta here is trial and error. We know that if we substitute theta equal to 0, somehow our equation here is satisfied. No? Sine 0, we have 0. And a number multiplied by 0 is 0. But we know that if our theta here is 0, at this point here, our spring is unstretched. So therefore, our theta here should not be 0. It should have a value. So what we do here is to do trial and error. So using your calculator, you may input this equation. We have sine. Let's just replace theta as x, no? We have alpha x. Then alpha equal 0.703 alpha x. No? So we have here our theta that is outside it trigonometric function, no? Outside sine, cosine, or tangent. So since outside siya, we should multiply or convert this theta into radians. So let's just multiply it by pi over 180 to make it in radians. Okay. By doing that, we may press shift, solve, and then our calculator would ask you solve for x, yes, and he wants to have an initial value for x kasi yung calculator natin, it's numerical, so it needs an initial value in order for our calculator to proceed finding the value of x. So say we start with 10, say 10 equal, what our calculator gave us is our value of x or our value of theta is 0. So like what I said here, what we want here is our theta not to be equal 0. So for our trial and error, we increase our value, no, until we get a value of theta that is not equal to 0. So let's try 20. So shift solve 20, still 0. So we need to increase it more. We have shift solve, say we have 70. No, theta is 70. So we have now a value of 80.34. So our theta here should be 80.34 degrees. Ayan. That is using trial and error. Okay. And as you can see here, we have L minus R is equal to 0. That means that the left side of our equation minus the right side of our equation is 0. That would mean that this left side and right side, they are equal if our value of theta is 80.34. Okay.